Last video we were talking about SSS and SAS as two ways of proving triangle congruence without having to prove all the angles and all the sides congruent. Well, now we get to add three more congruence postulates to our tool belt. And to start off the conversation, last time we talked about what was called an included angle. And if you remember, an included angle was an angle between the two sides we were proving congruent. Well, in this case, we're going to talk about an included side. Now, in this triangle, if we were to prove angle P congruent to whatever angle in the other triangle, and angle Q congruent to whatever angle in the other triangle that we were trying to prove congruence with, then the included side with those two angles is the one between the two angles, and that's side PQ. So just know the term included side, which brings me to the point about this idea of angles, two angles and a side, and that is we can prove congruence between two triangles, let's say A, B, and C, and triangle D, E, and F by using two angles, A and D, F and B, as long as we also have the side between them, in this case AB and DF, or the included side. So we can say these two triangles are equal because angle A is congruent to angle F, angle D, angle B is congruent to angle F, and side AB is congruent to side DF by angle, side, angle. Unlike side, angle doesn't always have to be the included side. We can also use two angles and then the next side over. So let me show you what that looks like. If I have triangle A, B, C, and D, E, F, I can use angle A, angle B, and side C. If I have angle D, angle E, and side F. And this one is called angle, side, in that order. The last one I can use is kind of derivation on that side, angle, side postulate. And that's because we're going to use something called hypotenuse leg. And as it sounds, hypotenuse leg has to deal with specifically two right triangles being congruent to each other. And what hypotenuse leg says is as long as I have the hypotenuse congruent and one of the legs, doesn't matter which one, congruent to the other leg, then I've got two congruent right triangles. And that has to do with the same idea of side, angle, side, although in this case it's more like side, side, angle, but it only works because it's a right triangle hypotenuse leg theorem. So that would be congruent with hypotenuse, or hypotenuse leg theorem. Yeah, 4, 5, 4.